In this video, I'm going to highlight the effect of electrons with respect to the size of your atoms. Now, as you can see here, I have several atoms to represent the periodic table. So we have hydrogen, lithium, and sodium. They all three of them belongs to group 1A. And we have elements in period 2. We have, or from left to right. So we have lithium, beryllium, and neon. In this video, I'm going to highlight the effect of the number of electrons with respect to the size of the atom. So here on your right, you'll see several atoms that represent the periodic table. Hydrogen, lithium, and sodium, they all belong to group 1A, so from top to bottom. Okay. And here on period 2, we have three elements, lithium, beryllium, and of course your noble gas neon. Now you can see that the electrons here vary, or the number of electrons vary, and as you go from top to bottom of the periodic table, or as you go down the family or the group number, you're going to see the number of electrons for your atom increases, and because of that, it's going to need to occupy more and more energy levels. So that makes sense that as you go down the periodic table, the size of your atom increases. So if I'm going to give you on the test a list of elements in the same family or same group number, and I'm going to ask you to arrange them according to their size from smallest to highest or highest to smallest, then you should be able to do that. Okay, so as you go down the periodic table, the size increases. Now the phenomena is really different as you go from left to right or across the periodic table. As you can see, the number of energy levels, and this is the example for period 2. In period 2 elements, these elements will only require 2 energy levels. The electrons can fit in 2 energy levels. So the electrons in the outermost shell is actually not pretty much similar in proximity to the nucleus. Okay, I'm going to change the color here and say the nucleus will have the color blue. Okay, so right here. All right. Now, how can we tell the size? You would think that as you go from left to right, the number of electron also increases. So you would think that as you go from left to right, the size will also increase, but that's not the case. As you can tell, these electrons can fit in second energy level. The number of energy level as you go across the periodic table did not increase. However, if you look closely, the number of protons present inside the nucleus has increased as you go from left to right. Now remember, these protons are positively charged species. So think of it like magnets. These electrons are drawn into the core because as you go from left to right or across the periodic table, the number of protons has increased. So now the magnetic effect inside the nucleus has dramatically increased. So you're going to notice that the rings or these energy level have a shrinking effect. So as you go from left to right, the size actually decreases. So neon is actually smaller in size, in radius, or in diameter. I'm sorry, so we're thinking of an atom, so we're looking at diameter. So the size of neon is actually smaller compared to beryllium, and lithium is actually bigger compared to these two atoms. So it's opposite in trend. As you go from left to right, the size decreases, or you can also think at it the other way. As you go from right to left, the size increases. So think of this as the fulcrum here on the upper left part of your periodic table. You notice the trend as you go counterclockwise, right to left, top to bottom, the size actually increases. So let's have some example. So we have carbon, nitrogen, and say lithium. And I'm going to ask you to arrange them according to their size, to increasing size. So notice carbon is right here. Your nitrogen is to the right of carbon, and lithium is on the leftmost. So remember, as you go from right to left, the size of the atom increases. So the biggest element here is lithium, contrast to carbon, and then the smallest will be nitrogen. So if you're asked to arrange it according to increasing size, it will be nitrogen is the smallest, followed by the carbon, followed by the lithium. So lithium here is the biggest, as you can see from this less than sign. Carbon is less than lithium. All right. So if you're asked elements in across the periodic table or down the periodic table, so we have, say, potassium, rubidium versus sodium, and you're asked to arrange them according to size. So we have potassium, rubidium, sodium. Sodium is the smallest, followed by potassium, and of course the biggest there is rubidium. It just makes sense because as you go down the periodic table, you're going to need more and more energy level. And let's see if you guys have retained this information with several exercises.